Get it as quick as we can. Okay, good afternoon again, ladies and gentlemen. You're all welcome back after the lunch break. So the afternoon's session will focus with two presentations on the biochar sector. So the biochar area is a growing sector in Ireland. IrBEA has been involved in this space for a number of years, and particularly through our European projects in this area. IrBEA biochar members span the full supply chain from biomass suppliers, project developers, biochar producers, pyrolysis and kiln technology providers, biochar users and product developers. And we also have a wide range of consultants and service providers to the sector. IrBEA is the representative body in this area, and we have also a membership of BioChar Europe. And you'll hear in our presentations about various projects which are coming on stream in the sector. And I'd like to first introduce you to Professor J.J. Leahy. J.J. is a senior lecturer at the University of Limerick. J.J. is a leading researcher in bioenergy, biofuels and waste-to-energy technologies, and he has a very extensive experience at the intersection of academia, industry and policy, and contributing to a number of national and European projects in collaboration with organisations including Teagasc. His research focus on developing sustainable solutions for converting waste into valuable byproducts, supporting the transition to a circular bioeconomy. Professor Leahy has secured significant research funding and maintains strong industry partnerships, helping to drive innovation in Ireland's renewable energy and agri-food sectors. And the title of JJ's presentation today is outlining the Just Transition funded BIOCHAR Project and the opportunities for the sector in Ireland. And I'm delighted to welcome a number of the project partners here today for having the exhibition stand on site here today as well. So now hand over to JJ, who will take you through an overview of this particular project. So over to you, JJ.
Thanks, Sean, and thanks again for giving me the opportunity to speak today about this project. It's just kicking off at the moment, even though I've been working on biochar projects for the last 15 years, so I'm familiar with a good number of the people here in the room. This project is different in that it's only Irish partners. It's funded through DAFM and by the Just Transition Fund. And the key thing about this project, I think that there are a couple of differences between this project and other projects. Number one, it's based specifically in the Just Transition region. So it's the primary goal is to benefit, to have a social and economic benefit to, I suppose, the region itself, because they have suffered the consequences of the loss of the peat harvesting for the 3 thermal power stations which used peat. So the USP of our project, and it differs from other biochar projects, in that it's going to be driven by market demand. So it's going to be application driven. So we're going to develop materials specific for a number of product applications. And I'm going to speak about those in a moment. We're going to use a number of indigenous feedstocks. Some are energy crops. Some of the crops are what I would call agri-waste. And some of the crops, for better or for worse, will have to be paid for. And that's going to make the biochar more expensive. So the likes of miscanthus, short rotation willow, that's going to involve buying the material so farmers will benefit. Cereal husks from the likes of oats are obviously an agri-residue. We'll have wood processing residue and green waste. So we're going to look at the entire JTF region, and we will be demonstrating we'll have a number of demonstration sites. I suppose what's unusual about this project as well is we want to encourage people to become involved in the supply chain and logistics for biochar production. So we're going to offer an innovation voucher scheme where people from the Just Transition region can apply, and we will subsidize them in order to develop some businesses which could be related to any part of the biochar chain. And we're going to develop business models then for the use. Now, because if you look at what has happened in Australia with biochar, there are small volume, high-value applications for things like golf courses. There are large volume, low-value applications within using biochar on soil, for instance. So there are a number of different applications, and there will be different business models pertaining to these. And the business models will depend on the feedstock availability, the feedstock choice. If you have to pay for your miscanthus or your willow, then your biochar plant may not be viable. If your feedstock is free, or you're charging a gate fee for it, then the viability of your plant changes, and the business model should respond to that. I'm going to see if this works. So what we're doing is, this is going to be, our project, the biochar, is going to be specification driven. So we're at the moment, we're testing at a very, very small scale. We're producing kilo scale amounts of biochar. Once we've produced the kilo scale, we're going to test those for the specific applications at a very small scale. We're then going to produce 20 kilograms of each of the specified biochars, and we're going to test these likewise for the applications. So we're going to use some of these in road making materials. It's going to be used in asphalt, for instance. And so we will test it in the lab. We will make 1 meter by 1 meter samples of asphalt, and we will test that against the standard which is currently in place for road making materials. And then we're going to go to what we call full scale. And with full scale, we're going to produce between 30 to 50 tons of biochar to meet the desired specification, and then we're going to test these at full scale. In the case of the asphalt, we're going to be laying down roads. These are likely to be non-load bearing roads. And Transport for Ireland will permit us to use up to 5% biochar in the asphalt. When I say non-load bearing roads, they're likely to be roads in housing estates. They won't be roads on the M. The M7 might not be the best place to test this, is the nicest way of putting it. And we're also going to use them on cycle paths. But the idea here, so we're going to use it both in the industrial sector, and we're going to use it within what we call the agricultural sector. And within the agricultural sector, we're going to have a cascade of use, because the cost of biochar can sometimes be prohibitively high. It's a bit like buying a Tesla motor car. I know I'm going to insult some Tesla owners here, but the problem with buying a Tesla is there's no second-hand market for it. And that has been the problem with biochar as well. So we want to create a second-hand market for the biochar. So we're going to develop biochars which can limit the emissions of ammonia, nitrogen in particular, from both in chicken houses and slurry tanks. These feedstocks are going to go into an anaerobic digester, because there is evidence there that biochar in anaerobic digesters increases the ratio of methane to carbon dioxide in the biogas. So your biogas plants become more efficient. If you were from any biogas plant, you're left with digestate. One of the big issues with digestate, to move that off-site onto land, you need a solids content in excess of 30%, ideally at 35%. The biochar within the digestate makes it much easier to achieve a solids content of 35%. The advantage of the biochar from the digestate is that it will be nutrient enriched. And this nutrient enriched biochar will go from the digestate tanks onto soil. So when it goes onto the soil, it will go onto the soil as it will have a nutrient value, but it will also have a carbon value. Oops. So the partnership involves a mixture of RPOs, such as us and Teagasc. We will have development agencies, such as the Western Development Commission. We have IrBEA, who's here today, who represent potential suppliers of both biochar, manufacturers of biochar, but also potential suppliers of the feedstock. We have policy experts, Climate Kick, we have roadstone, we're going to test it as well in water treatment plants, hopefully with Uisce Éireann on one of their sites, and Chemifloc are also one of the industrial partners. Chemifloc are the single largest provider of treatment products for the water and wastewater industry on the island. So as I said, we're going to use a mixture of feedstocks. We're going to have a biochar production, and from there we're going to test it on farms. We're going to test it on AD plants. We're going to test it as a water treatment agent, and we're going to test it in construction products. In terms of the technical impact that we hope we will have, well, we're going to develop reproducible biochar specifications. So this will be, so the specifications will be for the desired product. So this is hopefully will create a market pull rather than a market push for biochar. Once it goes onto the soil, we expect that we will see a crop yield from the biochar amended slurry or digestate. We're going to test the nutrient value against the Renure standard. So for people who are not in the agriculture sector, Renure is a very, very important standard for Ireland. It was passed by the European Parliament. It's integrated into the Nitrates Directive, and it offers the potential for farmers, Irish agriculture, to derogate up to 250 kgs per hectare per annum of nitrogen. So this is a really, really welcome addition. We will increase the soil carbon and carbon storage in both road-making materials, but also in soil. And we're going to measure this against the standard, the CRCF. There's a lot more detail emerging now on the requirements of the biochar. As part of this, we're going to develop what we call an MRV, a Measurement, Reporting and Validation Protocol for Ireland, which hopefully will meet the quality parameters that were spoken about earlier by Elena, so that we will have a tried and tested system so that we can apply for ETCS credits eventually for biochar in Irish soils and Irish roads. The likelihood is that it will be the cycle paths that will qualify in road-making materials, because most asphalt on heavy-duty roads tends to be lifted within a 5 to 7 year period. So it won't be seen as being permanently in the road-making asphalt. But for cycle paths would typically, because they're non-load-bearing, typically have a lifetime of 40 years plus. So we will we're going to remove some organic contaminants from water using the biochar, either treating water, but more than likely quaternary treatment of wastewater. We will be looking at the mechanical robustness and durability of the material in the roads, but also how we incorporate it into both the road-making materials and also into the anaerobic digesters. And with all of this, we're going to be looking at feedback from farmers in terms of ease of incorporation, application, so how well the users adapt to the material. Because making a business case, it's ultimately about how much the user is willing to pay. As I mentioned, we're going to have a biochar voucher scheme, and hopefully this will encourage more entrepreneurs from the JTF region to engage with learning how to use biochar and the potential benefits of it. Because along the entire supply chain, there will be a need for various actors to become involved. And the long-term impact for this, we hope, initially will be in the JTF region, but obviously the benefits ideally will be for Ireland as a whole. But we're going to target, at least for the next 5 years, or we're going to target that the impacts will be locally within the Just Transition region, because obviously we think that this is the area. Number one, we got the funding for Just Transition, and secondly, we think this is the area with the potential highest impact. So we're going to hopefully have impacts, will be both scientific, because we will develop specifications which will be related to the application. We will develop economic business models, so it will hopefully reduce the barrier for entry for investors. We will have societal benefits, and there will be environmental benefits. and I hope I will be back here next year reporting on some good results from this project. Thank you for your attention.
Thanks very much, JJ, for your presentation. Indeed, we're delighted to be part of the consortium, and we wish all partners the very best of luck in rolling out the project over the next number of years.